Alright, now let us begin with solubility of gases in a liquid. As you know, many of the gases, they are soluble in water, because of which many of the processes are possible. For example, if oxygen is not soluble in water, then no aquatic life could sustain. The fish and the plants, they breathe underwater because there is a considerable amount of oxygen dissolved in water. Similarly, carbon dioxide also dissolves to a large extent in water, because of which the photosynthesis process for aquatic plants also can occur. Moreover, you have seen that when you open a bottle of soft drinks, that carbon dioxide which was dissolved in water tends to come out with a fizz, and many of us we enjoy it. So what I mean to say is many of the gases are soluble in liquids such as water. Now the question is, what is the effect of temperature and pressure on the solubility of a gas? And of course, nature of gas also will play an important role. So you can see here there are three factors which affect the solubility of a gas in liquid. Number 1, temperature. Number 2, pressure. And number 3, nature of the gas. Now this solubility of a gas, that is the effect of pressure, is very well understood by a law called Henry's law. Very, very important law, Henry's law. Now what does the law state? It states that at a given temperature, mole fraction of a gas in solution. Here mole fraction is used as a measure of solubility. As you know, we have done so many concentration terms, mole fraction, percentage, molality, but Henry has chosen mole fraction as a measure of concentration. In other words, solubility is directly proportional to the partial pressure of the gas over the solution. That means if you have a liquid in which you are studying the solubility of a gas, and over the surface of the liquid you have the gas, then certain molecules of the gas will dissolve in the liquid. But if you exert a pressure on the gas, the more and more pressure you exert upon the gas, the more and more the gas will tend to dissolve in the liquid. And that is what is told by Henry by the name Henry's law. And the amount of gases which is dissolving in water is measured in terms of mole fraction. I would like you to refer to a figure given in your book. You please check. I don't remember the figure number. You will find it under the Henry's law. All of you must refer to your textbook. Every time, just don't depend on the notes. So next we move to the derivation of Henry's law. You can see here, if P with a subscript G, G stands for gas here, is a measure of partial pressure of the gas over the liquid, and chi G, again G stands for gas, is the mole fraction of the gas in the liquid, then according to Henry's law, Pg is directly proportional to chi G. You can see here Pg is directly proportional to chi G. That means more is the pressure over the gas, more will be the solubility. Now, when we have anything proportionality, we have to remove the proportionality sign by bringing in a constant. And the constant out here is Kh, which is called Henry's law constant. So, K with a subscript capital H stands for Henry's law constant. Now, if I want to define the constant, I have to keep the constant in one side and rest of the terms I have to take to the other side. So, by rearranging, what we notice here, Kh is equal to Pg by chi G. That means Kh is directly proportional to the pressure and inversely proportional to the mole fraction. This is a very, very important relation, because higher the Kh value, lower will be the solubility of the gas. This you can notice here. I have given you a table. Yes, you may check here. This table you can see here, where the different gases are being named at different temperatures and the Kh values are given. So you can see here, helium at 293 Kelvin has a Kh value 144.97, whereas hydrogen at the same temperature has a Kh value 69.16. So which gas is more soluble in water? Definitely helium will be less soluble and hydrogen will be more soluble in water. From where we got this relation? We got this answer by using this proportionality, that chi g is inversely proportional to kh. Is that clear? So this way, by knowing the value of kh, we can predict the solubility of a particular gas in a particular liquid. Moreover, just now we have seen that chi g is inversely proportional to T. That means if we heat a liquid, you may notice that bubbles tend to form inside the liquid surface. Now, what are these bubbles? The bubbles are actually the undissolved gases. That means the moment you try to heat the gases which were already dissolved in the water, they tend to come out because they no longer remain dissolved in water. How do we justify this? Check here. Check this. You see, when gas dissolves in a liquid, sorry, it is not solid, it has to be solution. Please make this correction, it has to be solution. So when gas dissolved in a liquid, it is actually change of state. You can see solid to liquid, liquid to gas. Solid to liquid is an endothermic process and liquid to solid is an exothermic process. Similarly, liquid to gas is an endothermic process, gas to liquid is an exothermic process. That means dissolution of gas in a liquid is an exothermic process. Please check here. Dissolution of gas is an exothermic process. So, and what happens to delta S? What happens to the entropy of the system? Since gases have maximum entropy, the moment they turn to liquid, their entropy decreases. So delta S also becomes negative. Now if we apply the formula delta G equal to delta H minus T delta S, what we notice? We replace the values here, I mean the signs of the terms delta H and delta S. We find that delta G is minus delta H plus T delta S. So what will happen when delta G will be negative? If delta H is more than T delta S, right? And how can you make delta H more than T delta S? You cannot change the value of delta H, you cannot change the value of delta S. It has to be temperature. So if the temperature is low, delta G will be negative. If temperature is high, delta G will be positive. Delta G negative means the process is spontaneous. Delta G positive means the process is non-spontaneous. That means the more we raise the temperature, the solubility of the gases tend to become less and less according to Le Chatelier's principle as well. So here you notice that Kh is directly proportional to T and chi G is inversely proportional to T. So what is the relationship between Kh and chi G? Kh and chi G, they are inversely proportional to each other. This is very well understood. Again, I will go back to the table. You can check here the table, the temperature dependence. Let us see. You can see here nitrogen and oxygen, they are given at two different temperatures, 293 and 393. So at 293, what is the value here? 76.48. And at 393, it is 88.84. Same gas, same liquid, but only we have changed the temperature. So what do you suggest? When nitrogen will be more soluble in water? At 393 Kelvin or 293 Kelvin? The answer will be based on how the chi G value is dependent on Kh. As we have seen, chi G is inversely proportional to Kh. That means higher the value of Kh, lower will be the solubility. And when the value of Kh is high, at high temperature. That means more and more we raise the temperature, the solubility of the gases tend to become less and less. I don't know how many of you have tasted boiled water and unboiled water. You will definitely find a difference in taste between the boiled water and unboiled water. Because in unboiled water, you have a lot of dissolved gases which impart some taste to water. Whereas when you are taking boiled water, those gases are expelled off and the taste changes considerably. Okay, now we come to the mathematical relationship between and the graphical representation of this Henry's law. You see, this equation Pg equal to Kh into chi g can be very well compared with y equal to mx plus c, which is the equation of a straight line. Now, here what is the value of y and what is the value of m and what is the value of c? You see, the value of y is Pg, value of m is Kh, which is a constant, value of x is chi g, and the value of c is 0. So, when c value is 0, what kind of straight line we get? Y equal to mx plus c, as all of you know, is the equation of a straight line. So, what kind of straight line you will get if the value of c is 0? The line will be passing through origin. That means there will be no y-intercept. The line will pass through the origin. So, if we plot a graph of Pg versus chi g, we shall be getting a line passing through the center having a positive slope. Now, at different temperature for the same gas, the slope might vary, and slope varies means, what is the meaning of slope here? Slope represents Kh, isn't it? Y equal to mx plus c, where m represents the slope. So, if we change the temperature, the slope is going to change, and slope is going to change means Kh value is going to change. It's very, very important point which you need to know from Henry's law.